Okay, this is the final type of polygon question that you need to really look at and be happy with. What we've got is a six-sided regular polygon, which is a regular hexagon. And what we've done is join from corner to corner, corner to corner, corner to corner to create this crossing over effect in the center of all these lines. Now, right bang in the middle where all the lines meet will be the center of the regular hexagon. And we're being asked to work out in this question the values of x, y and z. Now there's many ways of doing it, and you could indeed do the work of regular shapes to do with exterior angles like in previous videos to help you work out what x, y and z are. But I think in this particular case the easiest way to do this is to realize what's going on at the center. Because at the center, if you imagine going all the way round in a complete circle all the way round, all those angles in a complete circle all the way round must add up to 360. They've got to. And so what does that mean? It means that if you take that angle there, 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 and the x, they must add up to 360. Now because of the symmetry of the situation, there's these 6 angles and they're all going to be identical because of the symmetry. So if you want to get what x is, it's really simple to get x. All the way round at the center, all the way round must be 360. And if there's 1, 2, 3, 4, 5, 6 angles at the center, you just need to share by 6. And you immediately get the answer x is 60 degrees at the center. X is 60 degrees. And that's it. There is no need in this particular question to talk about exterior angles. It's as simple as that to get the x at the center there. Okay, now you need to work out what y and z is. So if I put 60 degrees there, the next thing you need to realize is if I draw these lines in like so, what we are creating is a triangle there, a triangle like so. I'll highlight it in red. There's a triangle. And from the center to the outside, from the center to the outside, this is what we call in maths an isosceles triangle. That is an isosceles triangle. Those two sides are the same length. Now, if you know anything about isosceles triangles, you'll know that the two angles in the corner opposite the two dash sides, in other words, the y and the z, opposite the double dash, those two angles I'm highlighting in green must be equal to each other. Right, so if you want to work out what y is, I do know it's going to be the same as z. They're going to be identical to each other because it's an isosceles triangle. That and that are the same length. That and that are the same length. And how do we work it out? Well, you know the angles in a triangle add up to 180. Okay, if I take away the 60 in the corner off it, which is the angle I know, which I've just worked out in red, so I take away the 60, and then I need between these two to share them by 2. So 180 for the whole triangle, take away the red 60, you get 120, and then share the answer by 2, you get 60 degrees for each of these two angles. So that must be 60, and that must be 60. So in this particular case, angle x is 60, angle y is 60, and angle z is 60. Now, this is a special case. Yes, I've said it's an isosceles triangle, but in fact, for a regular hexagon, what you in fact get is that is the same as that, yes, but they're all 60 degrees. So in fact, that triangle that you've got there actually turns out to be an equilateral triangle, 60, 60, and 60, for the regular hexagon. Right, well, let me show you with another example. If you're not confident, let me show you with this. This here is a regular octagon, and I've drawn the same basic outline with all the lines crossing, and that would be the center there. And I've got to work out the angle at the center first. This angle x is an angle at the center. So what I've got to do is do the following. What I've got to do is realize that this all the way around here is going to be 360 degrees in the same way that we had 360 in the last question. So all the way around at the center is 360. So if I want to work out what x is, because of the symmetry, each one of these angles, that one, 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 and that one, they're all the same. So if you take 360 and you share it by 8, because there's 8 of them at the center, you will end up with an answer of 45 degrees. So that angle X there is 45 degrees. So that's 45 degrees. So we're happy with that being 45 degrees. Now I've told you, I'll swap to a red now. I've told you that this here, this triangle I'm going to go over in red, is an isosceles triangle. Now in the previous one it happened to be equilateral. They all turn out to be 60 degrees, 60, 60, 60. Now this is not going to be equilateral. Notice that's 45 degrees. So it's not 60, 60, 60 this time. So it is just going to be an isosceles triangle. Those two sides are the same length. From the center to the corner, from the center to the corner, this is an isosceles triangle. If that's 45 degrees in the corner, we need to work out these two. Well, these two angles here, because of the isosceles triangle, are going to be the same. That Y is opposite that side, and that Z is opposite that side. The two equal sides are that one, and opposite them are the equal angles. So these two angles are identical. So if you want to work out what these two are from a Year 8 technique, I know that Y is going to be equal to Z. They're both the same. So 180 for a triangle, 180. If I take away the 45 in the corner, so if I take away the 45, I'm left with those two, and if they're both the same, share it by 2. So you end up with 180 take away 45 is 135, and then I've got to share by 2, you get 67.5 degrees. So that is 67.5, that is 67.5, and that one there is 45. So this one is not equilateral, it's an isosceles, 45, and then two angles of 67.5, and that's for the regular octagon. Right, one final calculation, then we'll look at the same idea but in a regular decagon. Okay, we've got an angle at the centre called X. All the way around, like so, must add up to 360 in a circle. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal angles. So we've got X will be equal 360 all the way around divided by 10, which is 36 degrees. So I know that that there is 36 degrees. Okay, now this again, if I go over this triangle that we've got to deal with in red, that triangle there is isosceles. I'll put 2 dashes on because this side there is not the same length as that. It's not an equilateral triangle like it was for the hexagon. This is a decagon, so it's just isosceles. So that's 36, but these two will be identical to each other. They're not 36 and they're not 60. How do we work them out? For the whole triangle, it's 180. So Y, I know, is going to be the same as Z. So 180 for the whole triangle, 180 for the whole triangle. And then if I take the 36 away from it, so I take away the 36, like so, what you're left with is just those two. If they're both the same, you share by 2 to cut them in half, because they're both the same. So you end up with 144 on the top, and you're going to share by 2. And if you do that, you get an answer of 72 degrees. So that would be 72, that would be 72, and the angle at the centre would be 36. And that is how you deal with this type of picture where you have a regular shape and they join up all these lines to create this cross effect with the centre right at the middle, and you have to work out the three angles inside this triangle. So again, it's a sort of a two-step process, and again I'll remind you, you don't need for this particular type of question to use exterior angle work. You can do it by basic 360 share by work and then the isosceles triangle, which is a Year 8 technique. And that's the end of this video.